Okay, continuing on today, doing some more integrals from the MIT Integration Bee from 2015. This one was number 6. We have the integral from 1 to e of x, natural log of x all squared dx. Okay, this one seems perfectly set up just to do integration by parts. We've got two things we're gonna wanna differentiate this and integrate this. I think what I wanna do instead though, I'm gonna actually do a u substitution to clean it up. This is kind of optional, maybe even slower, I don't know, but sometimes I like to do this just to do the cleanups. It's easier dealing with e to the x than ln x. I don't know, so let's just do this thing. So I'm gonna say u is equal to ln x, then rearranging solve for a value for x, we have x is gonna be e to the u. Take a derivative, we're gonna have dx is gonna be just e to the u du. So then we'll go ahead and substitute this. First, if we plug in e, natural log of e is gonna be just 1. Then plugging in 1, natural log of 1, it's just 0. Our x value here is going to be e to the u. Natural log x is u, so this is going to be a u squared, and for our dx we have eu du. But now we have the same base here and here, so let's combine these two and write this as e to the 2u. And now with what we have here, now we can do our integration by parts. What I'm going to do on this is the DI method or tabular integration. I think the reason I like it this way is because now we know that we can differentiate u squared all the way to 0. Maybe it's kind of a personal preference, but so I'm going to differentiate u squared and integrate e to the 2u. And then let's differentiate this a whole bunch of times. So we're going to have 2u for the first derivative of u squared. For the next one, derivative of this is going to be 2. One more time, derivative is just 0. Integrate this a bunch of times. We have e to the 2u. We bring a 2 out in the denominator. Do it again. Another 2. We're going to have a 4. One more time, we have e to u over 8. And now we're going to have part of our solution, actually our whole solution on the diagonals, was this is a 0, so it's going to wipe out the integral here at the end. So we'll just use this for our solution in u. I think what I'm going to do first is though, let's factor out e to the 2u, and I think I'll factor out e to the 2u over 8, trying to get some simplification. So for the first part, we're going to have a u squared. In order to make it work with this 2, this is going to be 4u squared. Here with the 2 and the 4, this is like a 1/2. So in order to make this work, I can do this as a minus 4u. And then for the last one, we're going to have just this 2 here. So I'll do it as a plus 2. And all we need to do is just evaluate this thing from 0 to 1. So first plugging in 1, we're going to have, this is going to become just e squared over 8. You plug 1 in here, this first part, this is going to become a 0. And we just have this plus 2. So we'll have a 2 over here. Next, evaluating at 0. E to the 0 is just 1, so we're going to have a 1/8. And then here it's going to wipe out this part, and we're going to have just this 2. So we'll have a 2 over here. I'll cancel 2 with 8 and get a 4. Cancel 2 with 8 and get a 4. Put it together, common denominator of 4. And so for my final solution of this, we have e squared minus 1 over 4. Okay, there you have it. Another one from MIT 2015. Thanks everyone for watching. Have a good day.